Okay, this is going to be a fairly quick video. This is a Dentron MLA-2500 that is original factory with all the ham bands in it. You know, this coil, that coil, and a bunch of fixed capacitors are switched in to give the extra capacitance needed for the ham band frequencies that it have. And this one's in the works, another MLA-2500B, to be mono banded. And that coil has been removed. And you can see all the band switch tie-in points on that coil. This part of the coil, which was an extension of this, is removed. It's again for 10 meters, 11 meters, you only need 3 or 4 turns of coil. But the reason I'm making this video is Dentron MLA-2500s are known to have a lot of harmonics and junk going around, and here's why. You know, all I did was cut out this coil so far in this one, and the wires going to the band switch. See all them wires underneath there? You know, all close, going to that band switch. That band switch got a lot going on. Not only is it switching the coil, you know, which is normal, it's switching in a lot of capacitors, a lot of fixed capacitors too. That's the plate DC blocking cap. The RF is coming out from the tubes, and mind you, this is unplugged, discharged, all this other stuff. So that's why I get comfortable sticking my fingers in. Don't do this at home, but anyway, that's the high voltage and the RF coming from the tubes. This cap here blocks the DC, the high voltage, unless the RF pass through. DC does not like going through a small cap, it won't. So the DC is stuck on this side, and only the RF can pass through that cap there. That's why they call it a blocking cap. But these caps underneath, that one underneath directly, and then those 3 going there, they're switched in to basically elongate that short cap there, the tune cap. If you see a lot of ham band amps, they have a big long, you know, tune cap that goes way out here. Well, I don't know if it was cost, because these things aren't cheap, but I think because of size, and they wanted to shrink this thing down and make it a compact amplifier, that they didn't use the big long, you know, caps to take out of room, a lot of room, the big long variables. They used a short variable for both the tune and the load, a little shorty. It doesn't have enough capacitance for the lower ham bands, so they switch in, you know, the extra capacitors here, these 4, as needed through the band switch, with all them contacts and wires going through it. That's, you know, right around the output area, and you know, around that too, all them wires and contacts going on. And also they do the same for the load here. You know, most ham bands, especially the load, they have a really big load cap, because the load needs a lot more capacitance, about 4 times more capacitance than the tune cap. You know, is what's needed to tune. So what they do again is they switch in those 2 at the bottom there, and those 2 under there. I disconnected some of them already, but they switched them in using the band switch to electrically lengthen that, or to give it more capacitance. But you have all them wires going around and all them connections, you know, right next to the output coming in here. And again, I'm going to go through routing right quick. The output goes, you know, through here into there. Then this one, it goes across the tune cap and then out to the tune coil. These are the same potential, so you could hook them together, but again, it's too much stuff in there. So they use, you know, one side is the RF going in, the output is going into this tune cap here. Then that normally would go out into the band switch and be switched for the different bands, along with the that cap and that cap. And then out of that would go into here, into the load cap. Then it goes through the load cap and then out this long one over to the relay. It's a lot of connections, and that was connected to the output side too, but it has been removed. Oh, you can see it right here, right? So it's hard to see all that going on, you know, with everything in it. And I just wanted to show that, and all those extra contacts and wires up close, very close to each other on the output network, and they interfere with each other. You know, RF radiates, and you get, you know, some radiation off of these, and it gets, you know, back into the output or where it's not supposed to be, and that creates harmonics. And it's not me. Look up the Ham's reviews on this amplifier. They say it's a good amp, but it's known to have a lot of parasitic and VHF oscillations that drive them crazy, and that's why. It's just a lot going on in a small space, and you got that long output, you know, wiring the way they did. So we may try to shrink it down a little bit, may not, but we've got a lot of that stuff out the way already with all them connections and stuff disconnected, and we're going to remove them doorknobs, and we could use them. And we weren't originally going to do that, but we wanted to get to that resistor there, which I think goes to the bias, and see why that's disconnected. And this amplifier, the B version, it has two bias diodes, and it has two voltages for the plate, you know, for high and low, where the non-B version, aka A version, or just the MLA-2500, no A, no B, it has 1 voltage for the plate, and hence one single bias diode. Alright, that's it for this one. Was I quick enough? Alright, bye.